Let's say that we want to transfer a secure message from computer to another computer, but the problem is that that message might be intercepted and read by the third parties. So to avoid that, what we do is we are taking that message, we are hiding that message. The the process of the hiding of that message is called encryption. And after encrypting that message that cannot be read by the third parties, even if the message is intercepted, we are sending over the wire to another computer. And another computer, when it receives that message, what it does is it takes the message, it does the reverse process of the decrypting message, and then that message is read by another computer. So we have two different kind of encryption algorithms that we use in order to transfer the messages, texts, and so on. So one of them is the symmetric and another one is the asymmetric encryption algorithms. Let's take a look at them one by one. The first one is the symmetric encryption algorithms. For the symmetric encryption algorithm, we are using the same key. The same key is used by sender and the receiver in order to encrypt or decrypt the message. So in symmetric encryption, the same key is used for to encrypt and decrypt the data. Both the sender and the receiver must have this shared key. So what are the popular algorithms that are used for the symmetric encryption algorithms for the symmetric encryption? The first one is that the advanced encryption standard is a fast, secure, and widely used. Also, we have data encryption standard. It's older and less secure. We have 3DES, which is that the improved version of the DES, but it's slower than the advanced encryption standard. Also, we have RC4 and the ChaCha20, other variation used in the specific applications. So to sum up, what is the advantages of using the symmetric encryption algorithm? The advantage is that the pro is that it's a fast, efficient for large data, and the biggest con is that the key distribution is tricky, meaning that how do you securely share the key? Another one is another set of the algorithms that we are using for the encryption is asymmetric encryption algorithms. So for that, we are using different key. We are using two keys. We call the public key and the private key. So we can, when we send the data, we can encrypt that with the public key, and that message can only be decrypted by the private key, or we can encrypt the message with the private key, and that message can only be decrypted by the public key. So what is the what is the advantage of using the asymmetric encryption algorithm, right? For privacy, we encrypt when we send the message with the receiver's public key, and for the authenticity, we encrypt or sign with the sender's private key. What's that mean? So let's take it step by step, right? So let's first take a look at in the asymmetric encryption, we have two keys: public key that everyone can see, that we are sharing with everyone, and the private key that only the owners, only the whoever has the secret has the private key. But depending on which one we are using for the encryption, the purpose changes completely. So what's that mean? So for example, let's say that if we encrypt with the receiver's public key, then the only receiver's private key can decrypt that message. So let's say that I'm sending someone a message, and I am encrypting that message with the private key, with the public key, and depending, let's say that 1,000 messages intercepted, right? And the message is intercepted, but it can be only read by someone who has the private key. So we are using that for the privacy. So even if the message is intercepted, it cannot be read by the third party, because only the owner of the private key will be able to read that message. But let's say we are encrypting with the private key, right? So you might think that, okay, if we are encrypting that with the private key, what's the purpose? Because that message can be read by anyone who has the public key. So it's not for privacy, so we cannot use that for privacy. That's exactly right, because we are using that in our case for the authenticity. So what we do is, so it's not about keeping the data secret, instead it's about authenticating the sender. So in our case, it proves that the message really came from the person who owns that private key. So that's how exactly the digital signature works. So when we are sending a data, so when we are sending a document, right? So we are using a digital signature, we are signing it with the private key, but the only way that anyone can verify that the data is coming from that specific source that is sending that data, it's come from the owner, is to use the public key. And if we are using the public key, then in that case, we can decrypt and we can read the message and we can verify that it's coming from the source. Let's take a look at the asymmetric encryption algorithms. The first one that is there is RCA. It's the most widely used algorithm for the asymmetric encryption. Another one is the elliptic curve cryptography. It's mainly used for the mobile and the IoT devices. We also have the DH algorithm, which is used mainly to securely exchange the symmetric keys. And we have DSA. So as the name suggests, it's used mainly for the digital signature. And we have the DSA, which is an improved version of the DSA algorithm.